we have another summation problem where we have to add the squares of natural numbers. They are consecutive, however, we don't start at 1. And this is the only formula we have. And factoring at 150 would not help with 151 or all the other numbers, right? So here is the trick. We're going to think of this as follows. Now this we could find, right? If this started with a 1 squared, and so on, then we could apply this formula where n is 200. That's good news, but that's not our problem. So what we can do is we can subtract what's extra, right? It's sort of smuggling. We added this piece because if we do so, now we can find this long sum, and then we subtract that same piece, because that piece that we smuggled in starts with a 1, so we can compute it as well. Another way to think about it is, I don't know if that helps, to think of something like this as, so basically we compute this, and then we compute this and subtract, and that will give us the piece. Be careful to slow down and figure out where do we stop. We do not stop at 150, we stop at 149. That's the only tricky part of this problem. Okay, so that's the plan. We're going to use this formula. So first we're going to apply it from 1 to 200, right? 1 squared plus 2 squared all the way to 200 squared. That is the same as this expression where n is 200. So let's do that. This here is 200 times 201 times 2 times 200 plus 1 is 401 divided by 6. And from that, we're going to subtract this sum, which is of the same form, but we're going from 1 till 149, so n has to be 149 here. N is 149, n plus 1 is 150, and 2n plus 1 should be 299. Yes, it is. 299 divided by 6. So the rest is just exercise on the calculator. Thank you for watching.